squared. And the total area is 32 inches squared, right? From the reference axes, what's the centroid to shape 1? What's the distance? Because that's y. That's what we're looking for. You've seen this already. 5? No. It's the distance from here, the centroid of shape 1 to the reference axis. So it's 8 plus half of 2, right? 8 plus half of 2 is 9, right? 9. The second shape from the reference axis is just half of 8, right? It's 4. 4. We take 8 times what? That's 90 and 54 is 144, right? This is in inches cubed, a volume. This is 64. Add these up. The sum of AY is equal to 208 inches cubed. Everything we've done right now is all chapter 5. Haven't it? Everything. The total area's moment is equal to the sum of the component area's moments. What theorem is that? It's Varigno's theorem, right? We can't get rid of this guy. No matter what we do, we're stuck with him to the end of the semester. Somebody do this for me. Divide 208 by 32. It's 6 point something, right?
6.5.
6.5, thank you. 6.5 inches. Now is where we're going to do chapter 6. Excuse me, chapter 9. This column I'm calling D, the transfer distance. It's the distance from the centroid of the composite shape. So we have to find that, right? It's right here. We just said that that's 7.5 inches, didn't we? So the transfer distance is the distance, I'm going to move that to over here, from the centroid of the individual shapes to the composite shape centroid. So that's D1, and this value right here, I'm going to move this A2, everything's right in the light. And that's D2. Does that make sense? How do you calculate that? It's really easy. You can either do some math here, but I'm going to teach you a simple way. If this is your y, look at your y bar. If this is bigger, subtract that from it. 9 minus 6.5, 2.5 inches, right? 2.5. That's the distance from here to here. Guaranteed. This one's bigger, subtract that one from it because it's got to be a positive number, right? 6.5 minus 4 is also 2.5, right? So the transfer distance was right in the middle of these two, only because they have the same amount of area, right? For y bar. I try to pick a problem that was easy. These are the two floor joists we put together. So, once I have that, AD squared is in inches to the 4th units. Look, it's right here. Can somebody give me this? 2.5 squared times 16.
100.
100?
Yeah.
Good. The sum of AD squared is equal to 200 inches to the 4th. Last column. I sub 0 x, because we're only doing it with respect to the x. You could do it with respect to the y if the problem asked, and then we'd have a couple more columns on here, right? We'd have a different d. Instead of dy here, it would have a dx, horizontal d. So that shines dy. And it would be dx if I was doing it with respect to the y-axis. But guess what? If I did it with respect to the y-axis and I put the axis right here, it's an axis of symmetry. D is 0. It all drops out. All I'm worried about is the moment of inertia. Something we'll talk about next class because we're definitely running out of time. But BH cubed over 12, we did this already, right? For both of these, it was 5.33 for the first one. And I think you said, Sam, right? You said 85.3? Good. So the sum of i's of this adjusts BH cubed over 12. Or you can look one up, if it's a structural member as part of this group, you just look it up in the table and add it right to the thing. We add these up. This is 90.66. 90.66 inches to the fourth unit, inches to the fourth unit. Look, the total moment of inertia with respect to the x is equal to the sum of its own capacity to resist bending, right, the individual pieces, plus their transfer distance. Look at how much the transfer distance, by adding these on top of each other, how much stiffer it got. Plus the sum of AD squared. That goes in here, that goes in here, you just add them up. 290.66, 291 inches to the fourth. Isototal x. 291. Meanwhile, before, when we looked at them individually, they were only 5.33 and 85.33. Once we mounted them together, 291. It's a huge difference, right? It got a lot stiffer. Yeah.
I just have a question about